Good day, students. Today we're going to look at a solution to another trigonometric problem. This is on page 86, number 9, practice 1 of chapter 8, the last chapter in book 3, the last chapter of the course. And it deals with right triangle trigonometry. Now, notice in this one, though, we are not given a diagram. So the first thing we're going to do is have to draw a right triangle. And I would recommend that you draw it and don't, just draw any right triangle and label it after. Okay. So I'm just going to draw a line down here. Okay, I'm going to go across to here, and so just roughly sketch a right triangle. Now, let's label that according to the information given. So read carefully. First thing I'm going to do is find out where the right angle is. Which letter is the right angle? It tells me right there. Angle S is a right angle. So I know S has to go here, right? Okay, so angle S is the right angle. So this letter must be angle S. Now, the other ones are R and T. It tells us that R is 22 centimeters. And T is 5 centimeters, and S is the right angle. Now, opposite S, of course, is little s, isn't it? So little s is going to be the hypotenuse, right? We use a lowercase letter to find that. So we know that little s is opposite there. That means if I put R here, for example, then opposite R, this angle R would be little r, wouldn't it? That's how you label it. So we know R. And we do know R, which is in this case is 22 centimeters. Okay? So that's how you label it. You label capital letter, and opposite that is the small letter. So if that's capital R, this must be little r, which is 22 centimeters. That means there's only one letter left. This has to be letter T down here. That means this side opposite T is, of course, little t, isn't it? Okay, and we are given that value, I think, as well. Yes, we are. We're given that to be 5 centimeters. So little t is equal to 5 centimeters. All right, let me just get rid of that. I'll just write t equals 5. All right, now look at what we're asked to find. We're asked to find the measures of the angles T and R. So I need this angle and this angle. Now the easiest way to do it, of course, is to find one of them and then subtract from 90, because we know in a right triangle these two angles, the acute angles of a right triangle, are complementary, right? Now you know that because all three angles add up to 180, and one of the angles is already 90, isn't it? So that means the other two must add up to 90 as well. So how do we go about finding angle R and angle T? You have to make a choice. Now let's look at our three primary ratios very quickly. We know the sine of an angle. Let's pick angle T, for example. Would be the ratio of its opposite side to the hypotenuse, right? The cosine of angle T is the ratio of its adjacent side to its hypotenuse. And the tan of the angle, so the tan of T would equal the opposite over adjacent, right? So you know these by definition. Now, if we're looking for angle T, we have to use the two sides we know. So if I look at angle T here, I go across T and I see a 5, so that's opposite. Okay, so I'll label this as opposite. And the other known side is this side right here. And since this is the hypotenuse over here, that 22 side must be the adjacent to angle T, right? So this is the adjacent side, and I'll put hypotenuse back here. Now we're looking for angle T. So use the two known sides. Which sides are known? Which sides have values, in other words? 5 and 22. That's the two we got to use. So we have to use opposite and adjacent. Now, which one of the three trig ratios uses opposite and adjacent? And it is tangent. So we must use tangent to find angle T. Now, how do you write it again? You write the word tan, and if you don't know the letter, if you don't know the angle, you write the capital letter of that angle up right next to it. So tan of angle T is the opposite side, which we do know, divided by the adjacent side. Now, remember how you do that. If you don't know the angle, then you have to use the inverse sign, right? The inverse of that ratio to get it. So now here's how you write it. Tan T equals 5 over 22. Therefore, angle T equals the inverse tan, which is tan to the minus 1 symbol, of 5 divided by 22. Now let me bring up the calculator and we'll do that together. Now again, every time I'm doing trigonometry, watch what I do. I hit my mode button. See my mode button there? Right next to the blue button, mode. And I go down and check the third line and make sure my calculator is in degrees, which it is. Okay? It's important that you're in degrees. If it's not, set it to degrees. Alright. So we're doing the inverse tan. Now the inverse tan is above the tan button, so you have to hit second. Anytime you're doing blue on your calculator, hit second button and then go to inverse tan. And then of course just put in 5 divided by 22, close bracket, enter. Now read your instructions. Does it say to the nearest angle or nearest degree? And it does. See that? Nearest degree. Therefore I'm going to write, even though the calculator gave me 12.8 degrees, I don't leave my answer like that. Let me just rewrite that 8. 12.8 degrees. Because it says to the nearest degree right here, I round that off to 13 degrees. So angle T is 13 degrees. So there's your first answer. Now you could do trigonometry again to find angle R, but we know that angle R plus angle T, right? Angle R plus angle T equals 90 degrees. If you add angle S to it, it would be 180, of course. So therefore, you know that R is equal to 90 subtract 13 degrees, which is, of course, 77 degrees. So find one of them using trigonometry. Find the other acute angle, right, by using subtraction from 90. They are complementary angles. And there's a solution to number 9 on page 86. Now the next video will move into the secondary or reciprocal trigonometric functions.